Welcome to the Advantech Technical Training. In this topic, we will talk about common system and control architecture. The target is to try to help you understand what is automation and control systems, and how this system works. The following is the outline to go through this topic. First of all, we are going to introduce a very general control principle. Then, we will introduce the IoT and automation architecture and how IoT and automation work. Also, explain the three scenarios for device connecting. In the final part, we will show you some common application classes and application stories. Okay, let's start with the control principle and development. The basic control principle has three processes: input, control action, and output. The complicated system includes many input, control, and output processes. For example, here is a water tank control system. We expect when the water is low can be automatic to input water, and stop input when the tank is full. Therefore, we need the high and low limited signal to be the input, and the control of the water source to turn on and off. At least we need logic for this system. Repeated these two logics, it will auto-keep the available level of the tank. This slide shows three basic and simple control logic: sequence, logical, and condition control. Sequence control means step by step to complete each process. Such do step 1 first, then step 2, then step 3. Logical control means it uses a logic gate to decide pass or failed, such as AND or NOT. Some chips inside the built-in complicated logic circuits. Condition control is using the condition function to do the decision. The input data have to match the conditions, then trigger the next actions. The above three control principle is being used in a complicated system. Time intervals can make all the control logic repeat and continue. For example, it can add a condition function into a process, then use time intervals to repeat the condition by 500 milliseconds until an exception. It can make the control system automatically do some actions without human control. A feedback loop is a common and powerful tool when designing a control system. Feedback loops take the system output into consideration, which enables the system to adjust its performance to meet the desired output response. A more complicated system will use feedback control, such as the tank level control system, use the level limited sensor to monitor the level. Limited sensor data is the feedback signal, which is used to ask the system when it should close to input the source. Some of the feedback systems feedback the signal very quickly to make the system modify the action, such as position detection, which will feedback the motor or machine's position to ask the system to speed up and off to do smooth control. A proportional, integral, derivative controller, i.e. PID controller or three-term controller, is a control loop mechanism employing feedback that is widely used in industrial control systems and a variety of other applications requiring continuously modulated control. The image of the right hand shows you the difference between PID and normal control. You can see the PID control will auto-adjust the response curve. It can make the control system more smooth. Most of the control processes will need software to achieve. PC-based control language is a high-level programming language that is used to develop logic and communication with machines such as C#, VB.NET, Python, and so on. Above programming language, you will need to develop the codes for the application, 5 lines or more than 1,000 lines. There is some graphic programming language such as LabVIEW, MATLAB, and Node-RED which can be used to develop the application. Usually, they provide rich function packets. And nowadays, web-based programming languages are becoming popular for developing web apps such as ASP, .NET, JavaScript, Node.js, and so on. PLC is a programmable logic controller. It is commonly used for the automation control units. Part 3 of IEC 61131 deals with basic software architecture and programming languages of the control program within PLC. Part 3 of IEC 61131 defines the standard PLC-based programming language, such as ladder, function block, sequential function chart, and so on. Most PLC control development software can develop these control languages. The top one in the world is Codesys. And most PLC manufacturers also make their own developed software tools to develop the PLC language. Human Machines Interface (HMI) and Supervisory Control and Data Acquisition (SCADA) software is a graphic user interface development tool. Normally, they are easy for the user who does not familiar with programming. Usually, they also allow users to write some script or Marco to develop the advanced functions and web GUI. Can do the basic control process. The common HMI provider such as GP Pro, 9, GT Designer, and Somatic HMI. Common SCADA providers such as WinCC, InTouch, iFix, Indusoft, WebAccess SCADA. Next, let's talk about the IoT and automation system architecture. There are three categories of IoT applications: Smart Service, Smart City, and Industry 4.0. Smart Service describes the most advanced level of database digital service offerings. They are provided by service providers to customers who use so-called smart devices. A smart city is an urban area that uses different types of electronic data collection sensors to supply information which is used to manage assets and resources efficiently. Industry 4.0 includes cyber-physical systems, the Internet of Things, cloud computing, and edge computing. Industry 4.0 is commonly referred to as the fourth industrial manufacturing revolution. The key elements of IoT include four layers. The first layer is sensors and devices with data acquisition units for the natural environment and machine information collection and sensing. The second layer will be IoT middleware and edge controller and computer. Built-in software that acts as a bridge between protocol or database and applications, especially on a network. Then, leverage cloud computing capability and benefit for system integration. The last layer is application software and system integration service. The service from the system for process, management, and decision-making includes the output from big data analysis, AI, and multi-system integration. The other key element is connecting interface, which is used to connect machine and machine, including cable and wireless communication technology. The four layers form the elements of the Internet of Things. How do IoT and automation work? Here is an example: how to monitor an athlete's sports status. The image shows an athlete doing a sport, and Belong connect with many monitor instruments. That's a past method to collect the sports data. Thanks to wearable technology, nowadays, we have sports watches and devices that can help us to collect sports data, such as the Apple Watch, Garmin, and Millet Health Watch. And you don't need any professional skills, then you can easy to get and monitor your sports status. It can easy to show your sports data including duration, pace, distance, GPS, heart rate, altitude, stride, cadence, calories, VO2 max, and so on. Most of the watch manufacturers also provide useful apps and dashboards to show your sport's historical process. Here shows the wearable device application architecture. It's similar to the IoT architecture which we just talked earlier. The data acquisition unit will be the sports watch, which has many small sensors inside. For most wearable devices, we'll need contact to your mobile phone or device to upload the collecting data and send it to the cloud data server. The smartphone equals the gateway and edge device. The data server will help you keep your historical data and do some analysis. After that, you can use your smartphone to download the data and review it. And you can see there is some connectivity technology including Bluetooth and LTE. The next generation of those data is we can think if those data can be feedback to the sports watch then coach athlete real time. Contrast the sports monitoring and return to the production situation. There are many signals and machines on the field side. If we can create an X device, which has the same function as a sports watch and gateway, then we can also link all the data and things together. If the gateway has connected to cloud features, then we can also leverage cloud computing benefits for managing and optimizing production. After connecting and collecting the data, it can generate a report and dashboard for production, such as work time, utilization rate, spec, yield rate, operation curve, device status, vibration, power consumption, temperature, humidity, pressure, and so on. Just similar to the sports data, we can also easy to monitor the production status and real-time information, make decisions, and have some action plan to improve productivity. To import the IoT into the field, there are three scenarios for device networking. There are three scenarios for device connection, including no communication interface and protocol, having a basic communication interface and protocol, and supporting a common communication interface and protocol. For no communication scenario, we can consider adding a sensor and communicated I/O module to collect the data and link each device. If the device has a basic communication interface, we can consider converting the interface to TCP Ethernet or wireless by using a device server or wireless access point. With a common communication interface, we can consider integrating the communication protocol to reduce upper convert loading. Or it also means to convert OT to IT interface. Next, we'll introduce some common application classes for control systems. There are 5 common control and monitoring architectures: separate smart and automation machine, intelligent production process, energy and environment sensing, preventive and maintenance, and intelligent cloud system. The smart and automated machine. PLC, PAC, and IPC/embedded PC could be the PC-based controller unit, integrating sensors, drives, and peripheral devices to complete the automatic processes, such as CNC, cutting, module, assembly machine, reflow furnace, 3D printer, robots, and any automatic equipment, are based on this architecture. Sensors and drives are mostly connected to the controller unit by a PC-based bus interface, and some peripheral devices use a communication interface. Here, controller units most use PC-based applications, VB, C#, RTOS, or real-time systems to be control logic. The intelligent production process is to connect each different system, including ERP, MES, WMS, and machine, include automachine, gateway, or can use extension I/O module to connect sensors and drives, to make different process units work and synchronize together. Connecting each process unit is usually through the communication interface, such as serial, Ethernet, wireless, and so on, with a specific communication protocol. Energy and environment are used to sense nature's signals, status, and equipment management. Usually, need to produce a management GUI. Through intranet and networking to connect each existing system and device to get monitoring and real-time data. This architecture is used in parking, surveillance, IAQ, energy management, water treatment, and power generation system. Preventive needs to get fast, mass, and tiny signals by the sensor, such as vibration, sound wave, pressure, and so on. Then through data analysis and algorithm to get feature value or abnormal operation curve to get the advance indicator to prevent the coming issue. Also, we'll need to record and alert functions to a warring operator to avoid production or loss of life and property. To leverage cloud service and computing capability, also to match access anytime and anywhere. This application is usually used in very wide usage scenarios, are cross-region management. Another application is to use get higher counting capability for data analysis, AI, and scalability. Cloud services include public and private clouds. Nowadays, the middleware become more important. The hardware built-in middleware could be a gateway or edge computer. The middleware is built-in software that acts as a bridge between protocol or databases or applications, especially on a network. Middleware usually supports multiple communication interfaces. It supports converting filed site machine data with different protocols to another site and protocol, to link data to a database, cloud service, or another upper system. There is some ready software tool that can help to do the configuration, and users also can develop their application by using PC-based language. Some new generation controllers have already built the middleware function without adding an additional gateway. Next, let's look at some application stories. AGV means automatic guided vehicle. It's an automatic machine that normally uses PLC or MCU to be a core controller. The core controller will access the sensor around the AGV for protection and safety functions, and will also detect the guiding signal to control the motor move and stop. In this application story, the core controller supports a basic communication interface and uses the EKI 1361 transfer to Wi-Fi communication. Through the Wi-Fi backbone built by our AP EKI 6311GN, the AGV Traffic Control Center can monitor each AGV's location and status. Status includes moving, low-level battery, accident, and so on. This is an example of a smart automation machine application. AOI, automated optical inspection, is to replace human eyes to do the quality detection of the production. It includes the motor control, CCD or CMOS camera, light, and lens. In this AOI machine normally use a PC-based control inside, to helping to do an optical inspection. The process will check the item position, take pictures, image analysis, feedback the result to the machine, doing the actions such as passing to good items or pick up failed items, then record the picture and counting to the data manufacturing center. It's another example of an automatic machine. There is normally more than one production machine in a factory, and normally one operator needs to take care of more than one machine in the production line. A light tower is a signal for checking machine status. If the machine does not allow or open the interface to access the status information, we can use remote I/O with a sensor to detect the status, and we can collect the real-time machine status in one monitoring table. When the monitoring system detects an exception to the machine, it can automatically inform the operator to help fix the trouble. HMI and SCADA software can be the monitoring system and generate managed dashboards showing the current production status. During this connecting and monitoring function, can upgrade managed behavior more efficiently. In some scenarios, customers should already have highly automated in each production machine. However, all the machines work individually and still need humans to do some paperwork to check recipes, check work orders, and record the production information. Since the customer has an existing controller with a basic communication interface, so it can be connected and integrated into the same network by using a data gateway. In the top layer, use SCADA to collect each station's data, connect to the IT SQL database, and generate managed dashboard for the operator and manager. Moreover, SCADA can provide mobile access function. When we need to review current production performance, we can use the app to check real-time data immediately. It makes information automatically and reduces the production duration. Visualization is to generate clear information for process to humans. A different layer of the operator may need to check different information, and managed layer also needs integration data for making a decision. Users can use PC-based programming language to develop specific user interfaces and dashboards in Windows form or web form. Non-programmers can use HMI or SCADA software to generate the same. The visualization display can show a kind of digital twin, process layout, key monitoring information table, or managed key index. The data source can connect from the machine directly, from the database server, or from the cloud. Integrating and analyzing the real process data can generate completed process information. And it could be shown on a display wall for managed layer. We call it an intelligent situation room. The display data of the situation room will not come from the field site machine directly. Usually, it will be counted and analyzed, such as production duration, utilization rate, and overall equipment effectiveness. And it may also include other system information such as ERP, MES, warehouse system, and so on. That information are help managed layers to quickly master the production situation or system situation, then make effective decisions to avoid the trouble and reduce the risk. Those data start from file-side data collection and integration, and it must be collected automatically. Then huge data become the useful information and case the information automatically. In the future, may be possible to have made decisions automatically by data science and AI. Thanks for your attention. Hope this course gave you Internet of Things common system and control architecture. If you are interested in advanced concepts and hands-on, you are welcome to join our product training courses. You will get a return with fruitful knowledge and skills. See you next time. Have a good learning day.